Good morning. Welcome back to mathematics class. Today, we'll be considering number bases, which we started last week. And we'll be considering further miscellaneous examples and exercise. The first one, the number 1621 was subtracted from 6244 in base x. If the result was 4323, we are asked to find x, that is the base. Let's represent the question in this way. This is subtracted from this to give us this result. So the first approach is we can convert all this into base 10. And you can see 6 times s to the power of 3, just as if you are converting to base 10. So we have this. Now next to this, express that as base 10 also. Then do same to the third one. Now 6s to the power of 3 plus 2s to the power of 2. That is the result of this one. Minus what was subtracted, which is this, to give us this result. Okay. Now, what happened to this is that all you have here will take negative sign, that is negative operation. So taking each of these from this left us with this equal to this. Now, I did this further, collecting the like times, so to say. I have this minus this minus this. When this one comes to this side, it becomes minus. When this one comes to this side, it becomes minus. This remains here to be plus. When this one is there, it's already plus. And when this one comes here, give us minus, all equal to 0. So you have s to the power of 3 minus 7s to the power of 2, all equal to 0. S to the power of 3 is equal to 7s squared. S squared we take away s squared of 3 of the 3 you have here. Therefore, s is equal to 7. Now, another way is for you to think that since you have 6 here, it means that the operation was carried out in a number system that is greater than 6. You may think of 7, you may think of 8, 9, 10. So what you do is 4 minus 1, of course, that will be, regardless of the number base, that will be 3. Okay, now you have 4 minus 2, which is not far from 2. Of course, 4 minus 2 will also be 2. Now, we are getting closer. Now you have 2 minus 6. That is where we have to consider now. 2 minus 6, that will not be possible. It means you have to borrow a packet from here. A packet that will be borrowed from here, inside it, there must be pieces of items that you have in that. Now, before we can have 3, it means whatever we be added to this one should give us something like that is greater than 6. That when we subtract 6 from it, it's going to leave us with what? 3. So are you thinking of having 6 with 2 to give us 8? Of course, 8 minus 2 will not give us 3. Now, what if it is 9? It means that the one you will be borrowing from here, inside it, it will be 7 items. So 7 items with 2 items will give you 9 items. Taking 6 from 9, you have 3. You can see we are getting closer. Now this will be what? We will be left with 5. Now 5 minus 1, that will be 4. So that is another way of thinking about this question. Now let me talk about other types of number system. We have decimal number system, which is base 10, and this is the commonest, is the most common number base that we use. You had 2 plus 2 to give you 4, that is base 10. You have you had money like 20 naira plus 20 naira to give you 40 naira, that is base 10. Now if you have it in other base, it will not give you the same answer. Binary number system, that is 2, base 2. While we have octal number system, which is base 8. Now hexadecimal number system, which is base 16. Let's go further. Example 3. Convert 5 in base 8 into decimal. So of course, converting to decimal means that you are converting to base 10. So which is very common that we always do. Now you have 2 to the times 8 to the power of 2 plus 1 times 8 to the power of 1 plus 5 times 8 to the power of 0 to give you this. This will be 2 times 64. How do you get 64? 8 squared. Okay. How do you get 8? 8 to the power of 1. How do you get this to be 5? That is 5 times times. How do you get 1? 8 to the power of 0. That is 1. So you have 128 plus 5 plus 8 to give you 141 in base 10. That is done. Now, number 4, in hexadecimal, the numbers are first represented just like in this decimal number, that is in this decimal system, that is from 0 to 1, and from 0 to 9. Then the numbers are further represented using the alphabet from A to F. You can see now 0 to 9. Then you have A, B, C, D, E, F. Okay. Now, having done that, let us. Oh, I omitted example 2. Sorry. Let's consider that. Write 14 in base 10 as a binary number. What you do is that you divide using 2 to divide 14 to give you, or you take your number, the answer from the bottom. You have 1110 base 2. So that is 14 in base 10 to give you this answer in base 2. Alright, that is considered. Now let us have the other part of the exercise. Converting 1056 in base 16 to an octal number. Octal number, the first thing you do is you have to consider, first thing, we need to convert the given hexadecimal number into decimal number. That is converting from base 16 to base 10. And what do you do to that? You can see we have in base 16, you see. How do we arrive at this? This 16, we are converting to base 10. Also this, also this, also this. So having done that, you now, just the same way we always do the other ones, you now use 8 to divide your answer, which gives us 10126 in base 8. Therefore, 1056, that is 1056 in base 16, is equal to 10126 in base 8. Now further, number 6, convert hexadecimal 2s to decimal. Okay, we need to convert 2c rather, in base 16 into binary number first. And to do that, 2c, just think of it, the other side, you have A, B, C. That is, you have, after 9, you have A, B, C. So what do you think you have after 9? 10, supposed to have 10. 11, you have 12. All right. So it means you automatically have something like 2, 1, 2, 1, 2, 3, like that. All right. You now convert this to base 2. Converting this to base 2, you have into decimal. Having done this, we've arrived at this to give us in base 2. Now we convert it to base 10, and that is the solution to that. Just take a look. Take a look. Thank you. In case of any question, please don't hesitate to ask. Now, the exercise which will serve as an assignment is convert 242 in base 10 to hexadecimal. 2. Convert 0.52 into an octal number. 3. Subtract 1101 in base 2 from 1010 in base 2. Then represent 5C6 in decimal. Thank you. I'm yours, Joy.